Since iOS 16 is now very easy to create charts in SwiftUI with the new SwiftCharts framework, and I did create here a little sample project to highlight all of these different chart types that you can generate. I'm just trying to show as many different examples. It is also important with charts to not overdo it. I studied physics, I have a PhD in physics, so I created quite a few charts and some of them were more confusing than others. With apps, it's a little bit different because when you show a chart, it needs to be self-explanatory and the user needs to understand what the information is. So these are all charts. They are more or less previews of the actual chart. For example, it's a bookstore statistics view. So you can see how many sales of books were in the last year, last 90 days. And then you can go to the detail and zoom in more to get more information. Maybe you want to exactly know how high the sales were in a specific week. Or you can do statistics over which week of the day is the highest selling. In this case, it's Saturday, and you can clearly see the comparison and which of these days, that's the highlighted one, is Saturday, so you see what the difference is. The cool thing about charts is really that you can compose and add more complexity to this chart. For example, you can add here toggles that show and hide specific information. For example, I want to hide the medium sales value of 50 sales per day, or show this, or maybe I want to show all the sales for all of the days to see how much the deviation is for each of these statistic values. And here you see all these values are pretty much around the average, so there is quite a good correlation between each day and the sales. The main thing is with this graph, I don't show everything at once because otherwise people would be like, what? So initially you only see this, and then the user can dial in more information. So we have quite a few different types of charts, and in this tutorial I'm going to show you what types we have, give you some examples. For example, we can have here pie charts. The good thing about these charts is you can nicely animate changes to the data. For example, if I here press the refresh button, in this demo I just randomly generate stuff and it animates the changes nicely. I also say here how much percentage of the sales this is. Then I have here a different kind of bar chart, so I just change the axis. I can also just show one single bar. Then down here I showed the total expenses over the last year, and I used an area chart. Don't really use area charts that much. I'm not really sure if most people like them. You can also use line charts, also with dots here. In this case, I have two different graphs for variable and fixed expenses. So the variable ones are much lower. And additionally to this graph, I also showed here a table, or this is actually a grid, just to where the user can easier skim through all of this data. This kind of graph is more like seeing the trend. And if the user wants to see more details, then he can use this here. You can also make these views interactable. That's what I showed here. So when I tap here, you can see the details. It's really a question of would the user actually do this? What information do I want to show? How much details? So there's quite a lot of things. Additionally, you can also do a lot of customization with the accents and legends and colors. For example, here I just hide all of the accents and the legends and just showed the trends or what I want to preview to not overwhelm the users. And I created this demo project to really test SwiftCharts, what it can do and how it actually works, especially with data handling. How much do I need to prepare the data, how the data looks like, how do I pass it? Because this is sometimes a little bit tricky. This is the beginning of a SwiftCharts series, and I'm going to first show you the basics. That means I'm showing you more simple examples and build up to more complex, especially in regards to what data, how do I need to structure my data, what does it take. And I also want to show you examples for each of these charts. In this tutorial, I'm not going to build the views that you saw in this demo. That's going to come in the more advanced part of the series, because in charts in an iOS app or in a macOS app, charts look the same on all platforms. They adapt to accessibility and dark mode, so they're quite nice for this. But you still need to design them very well. This is on one hand. And on the other hand, we need to understand our own data. How do we manipulate? What information can we extract? What do we want to show to the user? And there's quite a bit you can do. So let's start maybe a little bit more simple. And I also want to show you as many examples as possible to help you understand where to go. Let's jump into code. I simply added another folder to this bookstore strategy demo app. So you have all the examples together. And in my basic tutorial folder, you can find a link to the project in the description. I am going to create a new file where we can use static data. When working with charts, you need to import the charts framework. And I am using here a chart with the initializer of just content. And we are starting with looking for mark. So you have different ways of drawing styles. This is bar marks, area marks, line and ruler. We will see in a minute how they work, and I'm starting with bar. So you can decide if you want to, for example, have a range also, so it's not going from 0 to your value, but also a certain bar. The one I'm going to use is for X and Y, and you need to specify a plottable value, because basically the system needs to know also to understand a little bit more about the information. This is, for example, for accessibility, to know what name to give this value. And in this case, let's say type and then a value. This could be anything. You can use numbers or you can use a string. For example, I can say a bird. I have used now a string for the X value. And for the other side, I use the population. In this case, I use a number of 1. This is one value where I say how high is the bird population. For example, if you want to show statistics for the pets in Germany, I would want to have here 3 bars. So I simply add here 2 more of them. I rename this one to dog. And then this one to cat. And let's say cat should be higher than the other 2. Charts is one of these flexible views that tries to stretch. In order to make this just for this tutorial, I first use a padding and I use an aspect ratio of 1 with a content mode of fit. Let's just zoom in a little bit. As you see, X value, that's the X axis to show down here for bird, dog and cat. And what I use as the Y value is shown on this side, so 0, 1, 2, 3. With charts, you can add as many data points as you want to. Also, you can combine different types. For example, there is the rule mark, where you, for example, can say the start and end values. I only care about I want to have it the whole width, so the whole X range. So I don't want to specify X, which means that the system automatically uses the whole range that is shown. So I only want to have Y. So this is this one. Again, it's a plottable value. In this case, it's the average. And the value, let's just say 2. This is 1. Actually, it's more 1.5. It's shown on top of it. Right now, everything is using the default accent color. You can override this with the foreground style. For example, I can say gray for the ruler. And I can also change the colors for my bar marks. Let's say I want to highlight the most popular one. So I use a foreground style of indigo. What kind of colors you choose really depends on what your message is. If your message on top is the most popular pet in Germany is cats, then I would just highlight the cats and dim out the other 2. So instead of the foreground color, I could have also made added here opacity of 0.5, 0.5. So now you clearly look more at the cat bar. Additionally, you can also add annotations. For example, to my ruler mark, I definitely want to have an annotation. So I add the annotation to the marker that I have. In this case, it's the ruler mark. And say average of 1.5. And it appears next to this rule in the center. You can move it with the other properties here, like the position of leading. Okay, now it's using the leading edge. Now it's just using the leading one. And there is the alignment property. Bottom. Okay, you can use bottom leading, or you can also move this below. With this annotation, you can really decide on where to show this information. This is quite flexible. For example, maybe I don't want to always show this ruler mark and we want to toggle the visibility of this ruler. So first of all, actually I have to have a toggle and a state property, because this SwiftUI state private var average is shown, and in beginning let's just use false. Then I embed this in the VStack, and below I show the toggle average is shown. If this is true, then the title is show average, and otherwise hide average. And then I bind this to this property. Now I get here my toggle. Just need to move the padding. So I have now this state and the toggle, and we can adapt this charts. So for example, I can say I only show this ruler mark if my average is shown as true, and now it's not visible, and if I toggle this, it's shown. You can also, this kind of changes to the charts can be animated. For example, if I say the changes to this average is shown should be animated, now it fades in and out. This is the default behavior because this is one chart. You can also change these values dynamically. This is, for example, when I here change my whole data. Actually, I probably should use a bar chart. It moves it and updates it. So this is especially useful when you want to really make the user aware that something happened. Okay, so this was the first example where I really want to focus on how you can compose charts from multiple elements. You can add as much as you want to. From an UX user experience point of view, maybe not too much is better. Although it's quite hard to say how much is too much. So you need to do some testing definitely, or the UX designer need to do some testing. The next thing I want to focus on is what kind of data we can work with. Right now I just use here static data. This might be valuable if you are having example charts. If you for the first time launch an application, you want to show the user what kind of statistics they can expect, what kind of charts and information they can expect before they actually show fetch their real data or generate their real data. This would be probably okay. But as soon as you want to have more complex data, maybe larger data than just my 3 data points here, you need to really do more for the data management. So let's change this kind of chart for dynamic data with an array. So I create a new view here, which is dynamic chart view. Again, importing charts. And for now, I'm only going to copy here this chart about the ruler. Okay, so first we have to generate a data model. So in this case, I'm just going to put it here in the same file for simplicity for the demo. So this is a chart data thing. And this needs to have a property for the type bird, dog, or cat. Let type, this is a string. And I need to have here the population. You can also name this count number value. Then in this view, let's just create the data as an array of my chart data. So I had here bird as the first one with a count of 1. Then I had dog with a count of 2. And the last one is cat with a count of 3. Okay, now I want to move and change my data here. And similar with all containers in SwiftUI, you can use for each if you have an array or a collection of data. So I use here my data point in. Now because this is a for each, it needs to actually be identifiable. Most of the time you probably have an identifier by data definition anyway. I need to add here an ID, and in this case they're identified by the type. I won't have the 2 same types. I could also have defined this as an enum. So this is a string, return type. Okay, now it nicely works with the for each, and I can use one of these bar marks, maybe without the opacity for now. What I have to now change is, instead of this predefined value bird, I use my data point with the types. So that's now using the bird here, and then the value is data point dot count. And I'm going to remove these 2. Should have changed this to 3. Okay, now my chart updated. What I still want to have here is the opacity in this case. I have an opacity of 1 for the most popular type, which means that I need to set here different opacities depending on what data point I have. And I need to right now decide which is the max chart data point. So this is a chart data optional. And I can use a computer property to filter here and check maximum of this data by the count $1.count. So now I know the maximum one. Maximum returns an optional, that's why it's an optional. And now here I can use the opacity to say, okay, if the maximum chart type is equal to the data point I have here, then I know this is the maximum and I should use an opacity of 1, and otherwise I use 0.5, which it's complaining because I need to make my data equatable. So I'm just adding this here. And now you see I again have these different opacities. I could have also used here the foreground style and changed the colors to use gray and then one colored here. So this would be foreground style color.gray, no, color.accent color, and otherwise color.gray. So instead of the opacity. Now, okay, I probably should not have done this. Let's do this too. So I use both the color, foreground style, and the opacity to really highlight the important thing in this chart that I want to make the user aware of. As you see, I have now here an array of data points that we show in this chart. And now I want to step up one level in complexity to look at different data sets. And in particular, I want to see the popularity of this pet types over the years in Germany. I'm going to use this years for dog and cat to see how these popularity changed over the years. So I already added here a little folder for pet statistics where we can add this. Similar to before, I need to define the type, and I'm just going to create here a Swift file with pet data. This needs to be identifiable. And in this case, I said I want to show the changes over time. And I have data for each year, so I know that I have a year property. You might also have dates, which it can handle very nicely too. Then I have the population, which is a double. And in this case, I'm using data where the population is in million. I need to have an ID property. And the one thing that is unique about this model is the year. I won't have 2 times the same year, so I'm using that in year. Because I'm going to use this data a little bit more, I am going to create 2 static arrays here that we can also just test things with. So for one example, for cats, so this is a computed property. And then we have another example for dogs. I actually used the proper data. This is the number of pets in Germany from 2000 to 2022 by type of animal in millions. And this is a chart you probably should not show like this in an app because it's way too much information. And so you see here we have an increase in cats and dogs, pretty much doubling in this 20 years. And I used this 4 data points for each of these cats and dogs. And I want to now show a similar graph as you saw before, or maybe not the same complexity in my app. So I am going to create a new view. This is a pet statistics view. Again, then import charts. And the first thing is I need to actually have access to my data. This is cat data, where I just go and get the data from my examples. And then I have another array for dog data, and I use the dog examples. Now let's work on a chart. And in this case, I want to show for each of these 2 arrays with a bar mark of X and Y. So this is year for X with the value of data year, and the other axis is the population with the values of the data's population. This graph doesn't look amazing. This is because per default charts always tries to guess automatically how the axes look like. In the previous examples, it worked pretty well, but in this case, it doesn't know we are talking about years, and that I don't want to start at 0. So let's just change the chart X scale for domain. So this is scale domain. I can use here a range of 2090. Actually, I want to use 2000 to 2022. Now you see it's actually going to the edges, so I'm going a little bit below 1998 and 2024. So they move a little bit inwards. Just adding aspect ratio of fit so you can see the other data points. So then I generate a second for each for my dog data. And now you see the effect, and maybe I should just undo and redo this. So I'm just taking this out because it's a important learning. So I now only use the cat data, which was the highest at 15 million here. And now when I add the second one, the array of dogs, and now you see the statistic for cat and dog together. So basically the chart automatically sees, oh, for the same X value, I added another value, so it adds them automatically. You can change this or see this also if I use a foreground style of indigo, or I just use orange. You can really see that it adds these values up to create this bar chart. This kind of behavior helps when you have large data that you want to sum up easier, so you don't actually need to do so much work on your side. I'm going to show you more examples of this in the future. In this example, I had to use here 2 for each of my data series. But maybe you have a lot more series, like actually in the original chart where there is 7 different types. Maybe then adding here 7 of these for each, especially with the different stylings, is a little bit too cumbersome. So how do we wrap this data in a more convenient way to only deal with one array? And I'm just going to do this in the same file here. So we can talk about how to prepare the data. And I am going to create a second view and basically copying the whole system for now. So one way of doing this is, as I said, I need to collect all my data series in one array. So this would be my data that I want to work with. And now the question is what type of array we want to use. It needs to be array because for each works with random access collection, so it needs to be having an order, identifiable data, or specifying an ID. So I can't use dictionaries because they're not ordered, but you can use an array of tuple. So for example, the first tuple value is the type. So this is string, either it's a cat or a dog or a bird. And then the second is the pet data array itself. Okay, now I can construct this array from type, which is cat, and then I use the pet data, which is my cat data. This is really just a wrapper for convenience working with these charts. The type of the second data series is dog, and the values that I want to show are in the pet data array for dog data. I use the computed property just to add another convenience layer. Okay, now we can change our little chart. I remove the second for each, and we start with a for each for our data. This is an array of tuples and it's not identifiable, so I need to add here an ID, and I use the type. This is a data series, and in this data series has now my pet data, similar to before here. I can use the data series pet data, and obviously I need to create another preview with Xcode 15. I can just say second, generate a second preview here, and I actually need to use the second view that I created. Again, the charts looks the same. I want to have different colors, and for this I use the foreground style like before with the by, because this is now giving a value of pet type, and the value is the data series is what's it, type. Now I have these two different colors. This is the default blue and green. To make this example a little bit more interesting, I'm going to just change this here to a line mark, which is probably much more appropriate for this because you see really the trend over the years. When both of these became more popular, you can also directly add here a symbol, same styling of differentiate my data by the data series type. And now I have here a circle and a square. Just probably have to zoom in. A circle and a square for this two different types. This helps for accessibility for people who are colorblind, that they have a chance to differentiate them. As you see, I have here only now one type of data that I work with. And this can also help me in making my chart a bit easier, because instead of using it for each, you can, similar to lists where you have for each, you can also directly use an initializer where you give the data. So this saves me from one level of indentation. Okay, as you saw, now I had here this collection of tuples. If you don't want to work with tuples, we can also create another wrapper model. So let's do this in a third iteration. Just copy this and call this third pet view, and then I have to also create another preview, just so we see that I did not mess up my data. Okay, as I said, I would generate a wrapper type, so you don't need to work here with these tuples. So let's just define a pet data series type of type. This is string, and pet data. This is then the array of pet data. Because I again have to work here with this for each, I again, actually this for each, I again can make my custom type here identifiable and then say ID is string and use the type. Now my data becomes an array of pet data series, where I give a pet data series for type cats and one for dog. And this saves me from here this one identifier, but otherwise it works the same. Just going to go in the third preview. So everything still works the same. It's just more a preference of how do you manage your data, where does it come from. In this example, I did generate my data in the views. For example, for this bookstore application, I created here a lengthy view model. This is my sales data property. The initializer, or when the view appears, I would at some point load this data from the server or fetch it from file system, set it to this array, and then all of these other properties are calculated from this, like the total sales, the median value, the sales per day, per week, per month, or weekday. And now I need to find a view where this is used. For example, in order to show here this preview for which day of the week is the most popular one with the highest sales, I here have a little text where I say what's the highest selling weekday, which is the one that I'm taking from, that I'm actually calculating my view model, so I'm getting that here. I'm showing here the statistics, and then in this chart I show this average sales by weekday data. So the data comes from the view model. Another example is here when I show the best-selling books for book category. So again, I get my data from the sales view model, where I fetch the data from the server probably. Right now just the dummy ones. I'm also setting here the dummy values in the preview. I have here this picker where I can decide showing different charts. So this is the picker with the for each saying which charts I show. And in this case, when I press this refresh button, I simply generate here another random sales data array. You would also fetch this from the server or refresh this from the server. I changed my data in the view model. This is the one I just told you, which is used to calculate all this information like the totals, and I think I had this total sales per category, where again for each category you get the sales information, the total number, which is the data that I'm showing here in this view. So I reset the data in my model that is then passed downwards to my charts, again to my view. And I do this here with an animation. This can be also done with this kind of charts. What I did in this case, I simply changed the values from X and Y to get the other way around. And when I refresh, I change my data, the chart gets new data and animates. This is also working when one of these charts, because now I actually do order this by the highest selling one. See, now these two change positions. They also changed the colors, but I guess I should have preset the colors, so it always uses the same colors. But let's not go too much into details. And this is a little bit about how do you calculate your data. Sometimes you need to calculate it, sometimes you don't. If I wanted to show here the totals, maybe we used this in the first one. If I want to show here the total sales, I wouldn't actually need to calculate anything by hand. I simply just hide the orange color foreground, and this is the total number of pets in Germany for each year. So sometimes it's quite convenient and can do quite a bit for you. The next thing I want to talk about is the different types of charts. We have to look at 7 different types, and I'm going to show you examples for each of them. You already saw some bar marks and line charts. I'm trying to give you more variety here. As an example for bar mark, I'm creating a view for each of them. So this is a bar chart example view. Let's say I want to show these bars for different pets, but I have more than just 3, and the list would be, we're getting a lot of data. And I want to show them in a vertical stack. Again, I use here this dummy data, only that I'm going to add one for fish and one for reptiles. Adding here 2 more, and I'm just going to take the same chart that we had before as a starting point, which I also need to again here import charts. So let's just focus on the data, which is why I only show here one type. As you see, it's a little bit too much. So what I do is I want to switch X and Y, and I can simply use for X the value count, and for Y I use the name. Now we have here the name of each of them. If you want to have a different color, I use foreground style value by type, and I use the data points type. Now I actually have here more additional information that I don't like. And just going to quickly show you examples for formatting. For example, I want to get rid of the legend here. I don't really need to have this because I see the name. So we start by chart legend visibility hidden. Then I don't really want to see the axis chart y-axis visibility. You can also hide this. Okay, that was not what I wanted, because now I lose my names. But I probably should just remove the X ones. Now what I want is, because I don't have the numbers, and I need to add the numbers with annotations. And I already know that I would like to have the position. And here the annotation is data points. Data points count. Okay, this was on the wrong position, so it should be trailing. So now it is on the edge. Obviously you can also change the color, or make this bold, or change the foreground color to gray if you want to have them less prominent. In order to remove the grid lines, I have to override chart y-axis, and in here define the axis marks, and to just use the axis value label. So this is the default one anyways. So in here I do get the value for each of these grids, and I can also specify to show grid lines. This does have you can also change the centered or the stroke or the colors of these, just so you know where to do this. But the main point was for me to get rid of them. The next one is a line chart, and for this, I guess the best example we already saw with here this line markers. I'm just going to move this example over there so you know which position. So this would be this example. Right now I added here with this symbol variants also point markers. If you only want to show point markers or scatter plots, We can also use a point chart example. That's going to copy the same styling over here. Import charts. And now the only difference is that I would here use point mark instead of a line mark. So everything works with different marks. Now we had bar, line, and point marks. And the next one is the area mark. So this is an area chart example view. Again, I'm using here the same example. And we move here to area. They will overlap. And what this does, it's actually adding them on top. So here I said that in, just go ahead and zoom in 2022, there were 15 million cats, so this is this point, and then 10 million dogs, so we are at 25 total. So you see, it's more area charts. In this case, it just adds them on top. The main information for area in this case is the total number of pets that are increased per year, and not so much the exact numbers for these two sections. Whereas here for this point or line marks, I can really see how each individual pet type evolved over time, changed over time. Okay, I don't think area marks are the most user-friendly in understanding, so maybe don't use them too much. Then the next example would be the rule chart example view. I always say ruler, but it's rule. This is for just showing one rule, one line. And we already saw examples where I just added them. For example, here showing an average. I'm just going to move this example over there. We change the color a little bit to highlight the rule. So in this case, I'm just making all of the bars gray with an opacity of 0.5. And then I just remove the whole. And now I change the average to blue. Well, actually, I don't need to because this is the default. And then maybe even change the foreground color to accent. And in this case, it's really the main focus of this chart is the average value. And you see how the other ones are fluctuating around this. Then with this ruler, you can also change this to show a range of Y values. So this would be Y start and Y end. Or you can also change the X position, or if you don't want to show it over the whole width, you can use the X start and X end, or everything together. So maybe you change this to, so you can restrict the whole rule a little bit. If you have very specific areas that you want to highlight, then there's another one, which is the rectangle mark. So this is another example. Rectangle chart example view, import charts. For example, I can use my cat data instead of this line chart to using it a little bit differently. So with this chart, again, you would use it for each, for this cat data point in. And now I would use a rectangle mark. For example, you can say the position X and Y, but also the size now with width and height. And these are, maybe just, again, the year, and the data points year. This is the same as before, population, and then I use the data points population, probably adding again my aspect ratio and the chart scale. So it automatically decides how large these rectangles become. But you could also now decide to say fixed or a ratio 0.5. This was probably not the best. This is probably doesn't really make sense in this case because I have distinct numbers. So fixed 20. So would use 20. And I think this is in points. If you want to use inset, this is the one that the coordinate system uses. So I have here 10 years. So if I use 2, so this is the given inset from the screen coordinates. And let's stick with fixed of 30. And you can also set the height to fixed of 2. So yeah, I add here this little markers. You probably would use this more to add some additional information or just one highlight of, okay, this is the reference value in your charts. Not like what I did here for my main values. And the last example is pie chart, which is newer for macOS 14 and iOS 17. Pie chart example view, and I need to import charts. This kind of pie charts or donut charts are good if you want to show ratios, and maybe in my case I want to show the overall ratio of cats and dogs. If I start again from my data points, and if I then want to compare them, I calculate the total populations of all these years. So I'm just using reduce to get the population, sum of all the populations over the years. This is more like an average of over all the years, but I don't care about the exact number. I just want to compare the how popular it is to pets. Then I'm just going to create a helper computed property which holds the type and the total amount that I just calculated. I also want to know which of these two pets is the more popular one. So I use another computed property to iterate through this data array and find the maximum, which is the amount, and then just return me the type. So now this is all the data preparations to actually add a chart for my data. This is not identifiable, so I use the ID by type data item in. So this is now the moment where I use the new mark, which is a sector mark, and you can specify the angle. This is the value that we are comparing here between these two total amounts. You can specify also the inner radius, angular inset. Maybe I use the simple one right now. Again, I use value of type and data items amount. As you see blue. It's basically a big blue spot. In order to see a little bit of a difference, I'm putting an angular inset of n.5. So this means it's going to add here a little bit of angle. So you at least see there is a difference. And maybe I add a frame of a height 300. So it's not that big. Now I have these two sections and I don't really know what is what. So the first thing that I can do is here actually add a opacity of if the data items type is equal to my maximum pet, then I say the opacity is 1, and otherwise it's 0.5. So my favorite dog breed is going to be highlighted. This is, for example, if you have the title above this of the most popular pet in Germany over the last 20 years is cats with this and this percentage. Okay, if you want to optimize this a little bit more, you can again use this foreground colors, foreground styles. You can add here a corner radius of 5. Now it adds here a little bit of rounding. Maybe I just put this to 15 shortly. You see here this is then rounded. Then you can also, if you want to have a donut, so you want to hide the inner circle, you can use the inner radius parameter here. Now again you can say fixed. Okay, in this case ratio should work 0.5. So it should only use half the radius. Is this half the radius? I think so. Okay, maybe I do this, make this a little bit smaller. And it does scale thanks to this ratio. In this case, it's probably better not to use a fixed value. And I'm going to take off my rather large corner radius. This is a nice looking chart. The difference for donuts and pie charts apparently is that for donuts, because now you have some space in the center, I can add here some information. For example, these pie charts I used for showing here the categories of books, of the sales. I use this little chart. You only see here the maximum one. You could also highlight the maximum, the best-selling categories, the 3 best-selling categories instead of just the first one. In this larger pie chart, I'm showing all of the sections with different colors also, including the legends and stuff. And I use here the background to add this title, giving the most important information about this section here, which is the fiction category. If you don't want to add this in the center as a donut, you can also make it smaller and then add here these titles. There's quite a few options depending on how much space you have. I'm going to wrap up here. You saw quite a few examples and I was mainly focusing on preparing your data. If you have here arrays of identifiable data for each, you can show a variety of things. What I actually did not show in an example, but I will show in another tutorial, is that you can also use here dates. That's also very convenient. I used here numbers or just strings categories. It's quite a flexible API. I showed you all of these 6 different charts of bar charts, line, point, area, adding here additional rulers, and then also this pie charts. I already touched a little bit on how to customize the look. For example, here, how do you set this range that is displayed? How do you hide the labels? A little bit about annotation, foreground styles, adding here symbol markers. You can also completely customize what kind of labels you're showing. When I started this, I didn't realize how vast the whole topic is. So with this is just the start, the more basic, so I can give you some ideas. And then I'm going to make further tutorials for building the whole UI that you saw in the sample demo. So building all of these views out. This is a cool project because it's a little bit, not just one view at a time, but also seeing how everything comes together. It hopefully also serves you as a reference guide. If you want to learn more about how to design and what to pay attention to when you create these views, I'm also creating another tutorial about 10 tips that improve the UX for your charts in your own SwiftUI apps. So you can also check that one out. Additionally, this whole charts works nicely in dark mode. You can also here check the color variants or the dynamic type variants. So it automatically makes the numbers here bigger. This is also working on macOS. It also has features for accessibility. It's very nicely designed. And just as a small comparison, I'm going to show you how these views look like on a different platform, like on macOS. I don't have macOS 14 installed, so I'm just adding here an availability checker to this view and also to the preview, otherwise this is not building. So in this case I used the navigation split view. Some of these views I used newer features like the scrollable. Here this is scrollable, this is newer. The same is for the selection. There's still a way to do the selection for lower iOS versions or macOS versions, but I didn't use this. Just as an example, you see this look pretty much the same. They nicely scale it down with the text. Same for this kind of chart. And the bar charts, and here also this line charts. The reason why it's white in this case is because I used a list which has a white background, whereas the other ones are only in stack views. The one thing to note about macOS is because I used here always this aspect ratio of 1, it will scale down your charts. So maybe you should add frames with minimum and maximum values so they don't get too big. For example, if I put this so big, I can't really see the whole chart in one go anymore. So I probably should use here a frame. You can also use charts on tvOS and on watchOS. And as you see, you don't really need to consider designing them differently or implementing them differently. Maybe a little bit of the sizing you need to consider that you don't, on the watch obviously you shouldn't put so much information. Thank you for watching. I hope it was helpful. Please leave a like. Until next time, happy coding.